One connection, 4 options. Today we are dealing with an everyday task in steel design. Two beams are to be connected to each other, and this can of course be done in various ways. Today's option 1. The double end plate connection. Here we use the end plate tool and then select the beams to be connected. We get a message asking whether the overlapping part of the profile should be removed or only be cut. In our case, remove is the right choice. Immediately after confirmation, the part selection opens, with which we can define the boltings exactly, because with bolts was selected in the default settings. By the way, this option is only available if the part assistant is activated. Alright, because Solid Steel always remembers the last setting used and the bolting fits here as well, I don't have to set anything else. Also, washers and nuts are already selected, otherwise they would be added with a click on default mountings. After confirmation, we receive an advice that the bore holes are located outside the end plate or that they overlap. Here we simply confirm with OK, because the dimensions of the end plate will now be edited. As you can see, the holes are automatically adjusted as soon as the dimensions are changed. Confirm and our end plate connection is finished. We continue with the second option, the clip angle connection. Same situation as before. Here we use the clip angle connection tool. The clip angle connection tool performs 4 tasks at once for us. It creates a coping, the holes in the profiles are bored, the clip angles are placed, and the screw connection is added. All in one step and controlled by a clearly arranged menu. We only need to select the profiles, define the shape and spacing of the coping, choose the appropriate clip angle and the desired screws. Done. I think you can't get any faster than that. Back at the start, here comes the third option. The connection with a small non-bending resistant end plate at the web of the beam. This time a coping is inserted first with the tool of the same name. The parameters are simply set as desired and then confirmed. Again, we use the end plate tool and define the target face by clicking on it. The size can be adjusted here, but I think it fits that way. The last steps for adding the end plate are defining which profile is to be shortened and which one is to be bored. Both is done by simply clicking on profile and face. Confirm and the end plate is in place. Let's add some bolts. The bolting is added via the create tool in part assistant. In the upper part of the menu, the screw, washers and nut are set. We define the clamping length by clicking on the start and the end faces of the hole. With this, the bolting is defined. We add the second screw via the pattern function, so I select linear here below. Patterning may be a bit overkill with only 2 screws, and it's probably even slower than simply placing a second screw. But you can see how fast this function is when using a large number of bolts in the video, creating pressure vessels, pipes and flanges. You'll find the link in the description. Okay, we continue in the pattern menu, which opens automatically after confirming. Here we only have to define the direction, the number and the distance, and our clip angle connection is finished. Now we are already at the fourth and last example of this video. Let's weld the beams together. To do this we use Solid Weld, our solution for detailed welding seam designed directly in the 3D model. But before we can weld, we cut the beam exactly to contour with the contour cutting tool. This works exactly as expected with a few clicks, and this is how the result looks like. Let's move to Solid Weld. Here we use the fillet and fix weld seams tool and activate the edge function at input. With this set for input, we can combine several edge segments to one continuous weld. Simply select one after the other, define the faces to be welded, and confirm. The preview shows us the weld seam, and if we like the preset thickness, we can confirm by clicking on Execute Next and start defining the second weld. By the way, the welds do not only look good, they are also inserted as a part in the model and can thus be used for calculations with, for example, the FER method. That's it for today. 4 COM connections were shown, and you now know how easy they are to design with our Apps for Creo Elements direct modeling. If you have any further questions, just contact us. And if you enjoyed the video, feel free to show it with a like or subscribe to the channel so you won't miss any new videos. Thanks for watching and see you next time.